Hello, everyone. Welcome to another Dapr community call. It's number 117. It's February 5th, 2025. Wow. Hi, I'm Mark Duiker, one of the Dapr community managers, and with me is...
Hi, everyone. I'm Celso Philip, also one of the Dapr community managers. Yeah, could you believe it's February already? Like February 2025?
Yeah, I was saying it.
Like Christmas just happened.
Yeah, exactly. Yeah, time is literally like flying. It goes way too fast. But thanks again for joining, everyone. Also, thanks to Dagrid for sponsoring our streaming software. So we are streaming to YouTube, Dapr YouTube, LinkedIn, and also X. YouTube is the best place for you to join us because then you can also interact with us. You can leave us some messages and we can also reply there. So please watch this on YouTube. And I definitely see some people already joining on YouTube. So hi, Laurent, and hi, Walter. Nice of you to join.
Yeah, it's always amazing for me to see like the different places that people join in from. So, we have some folks, I'm looking in the chat right now. We have some folks from Brazil, some folks from France. I'm in Florida right now. I know there's tons of folks all over the community from different parts of the world using Dapr. So it's always exciting to see everyone come together to just kind of, work together and do some amazing things with the product.
Definitely, yeah. And we do appreciate that you share where you come from, right? And what you're actually doing with Dapr. So we'd love to hear about that. So, and maybe you want to join one of these calls one day, right? So we definitely like to hear your story as well. And today we're going to hear from Mang. That's one of the Dapr Meteors, and he's going to talk about lessons learned from developing Dapr-based apps for production. So that sounds super useful information. I think I'll definitely learn a thing or two here. So welcome, Alex.
You guys can hear me, right? Every other Teams or Zoom meeting starts with that, so I think it's mandatory to say these days. So awesome to be here among friends, first and foremost.
Yeah, it's good to see you, man. Glad that you can make it.
Yeah, absolutely. And I know, Cecile, you were just saying you're almost can't believe it's February, right?
Yeah.
And I couldn't concur more because I was just reading your greeting card again from you guys. And that's why I was saying earlier, that it's so good to be among friends. Sometimes time passes so quickly that you don't realize that you may be missing a thing or two from your friends' life, right? But definitely a joy to be here. Thanks for having me.
So I'm really interested in your talk that you're going to have today, because I find like one of the things that folks always ask about is, okay, sure, I've seen the demo, I've seen the SDKs, you all talked about the APIs, I get it. But like, how do I really run it into production? Like, what are some of the things I need to think about from security and scaling and, backups and like all of like the ops stuff that I really need to think about as a business to make sure that, everything is running smoothly, right? So I'm really curious and interested to see what you're going to talk about.
So in all fairness, I'm going to be 100% blunt and honest with you all. This may as well be a very unstructured presentation, not what I usually have. And what I mean by that is that I usually have a bunch of slide decks and demos prepared and whatnot. And that's what I often do, especially at the conferences where you're always tight coupled. But with Mark mentioning the other, just before we started that I have more than 2 hours to speak, I said, yeah, sure. I'm just going to be an open conversation, right? I know I don't have 2 hours. That was a joke, you guys. Yeah, so just as an FYI, I'm streaming in from Romania, Transylvania to be specific. And I always say that twice because people think that I'm streaming in from Pennsylvania for some reason. No, this is the land of vampires on the other side of the world. And we are developing a bunch of Dapr apps here, if you believe it or not, in this side of the woods. But there's quite a lot actually that you can learn from developing Dapr-based applications in production. And I do have a slide deck, right? Because you cannot not have a slide deck. It would make it not a presentation if there wouldn't be one. But I'm probably going to slide away from it more often than you'd think. And I'm probably going to show you some code and things that do start from the quick starts and whatnot. But there are some things to take into account and to consider. So before going into the good stuff, let's start with the boring stuff. For those of you who don't know me yet, my name is Alex. I'm what they call a Dapr Meteor, as well as a Microsoft MVP and also Regional Director. But don't be fooled into believing that I work for Microsoft. I most certainly do not. I don't own a region, and my wife knows for a fact that I don't direct anything, that's for sure. But the reality is that I don't work, which to some extent gives me the opportunity of bashing Microsoft when they do things wrong, but also having a lot of flexibility into choosing my own products and my own technologies that I use for our application that we develop in our company. I run a company back at home. I have a team of talented developers, software developers, who have been developing Dapr-based applications literally, and I kid you not, since 2020. When Dapr was still a very, very beta project back in those days, but it was definitely production ready in my opinion. I've seen more mistakes than one would want, probably, especially into developing or implementing emerging technologies and frameworks and runtimes, as is the case with Dapr. And there are definitely some lessons that I've learned throughout the years of developing and considering these applications. So, shall we get started?
Yeah, let's do it.
Let's do it. So I trust that everybody here probably is already well aware of what Dapr is and how it works and what Dapr is all about and the bits and pieces about Dapr. Here's a picture of me on my slide deck, because why not? But the reality is that when you think about developing enterprise applications, and I fancy these two words together, enterprise applications, as if they were not software applications, they were something else. They were a bit more special. The reality is that there are some requirements that you see recurringly, and I would argue that every other application, enterprise-y or not, should all be scalable. They should all be distributed to some extent. They always interact with external services, whether you want it or not, right? There's always going to be a database. There's always going to be some sort of identity provider system, and they all have to be resilient. Also, as a software developer, when you start in the software industry, you're always promised with this cool set of programming languages and the flexibility and almost exotic nature of your programming language of choice and whatnot. But before you know it, you have to start learning Ansible and ARM and Bicep and Kubernetes and Terraform and God knows what other technology. And then they sprinkle in some CI/CD because, well, that's the way to do things these days and so forth. And they kind of take away the fun out of developing software. Also, there's this problem of emerging technologies and everybody trending towards whatever they call serverless and platforms. And, you get these enforcements and these dependencies on writing very specific code, boilerplate code to an infrastructure. And that's in my books, that's anything but sexy, right? It's not what you should want as a software developer. You don't want to have a server next to you. That's what I used to do 20 years ago. I had an IBM X 3650 M2. I would know exactly the processor, the hardware, and whatever else I was developing upon, and that was it. But these days, you want to develop almost like you're building Legos, building blocks. And there has to be some sort of a runtime or a framework of sorts that allows you with the flexibility of just writing code and then just, well, in a utopic world, just forget about it and it just always works. Of course, we're not there yet, but in my books, Dapr has the ability of doing that. And when I'm looking, and in all fairness, many of you probably already know these slides because they are taken from the Dapr resources to begin with. If you look at these supposed commonly known applications, which to some extent are considered distributed, if you take an e-commerce application, there's always going to be some sort of a front end which facades a bunch of services, but rather than calling those services directly, you have some sort of a gateway. And then the gateway is responsible of calling, say, the shopping cart microservice and the checkout microservice and the inventory microservice and whatnot. And they're sometimes called directly, sometimes they're called indirectly. And before you know it, you write a lot of different small projects. If you use Visual Studio, to bundle them together into one large solution, and you hope everything would work. And to some extent, you may consider this microservices, but in all fairness, it is not unless you do some things. And this is where the things that we have learned from developing production applications or production-ready applications with Dapr really comes into play. In all fairness, a lot of the things we have learned are from books like these, from Sam Newman on building microservices, learning the intricacies of not having HTTP chain, learning of the intricacies of having dependencies. There are small decisions that seem trivial at some point when you're writing a brand new greenfield application, such as, should we have one project with a bunch of classes inside and then just share them and reference them together? Should we create a NuGet package and share that across all of our C# based projects? What about a different project that doesn't use NuGet? as a package management system. What do you do with service invocations and calls? Should we have service invocations directly or not? And then you look at runtimes. Dapr does provide service-to-service invocation, and it actually abstracts networking and retries fantastically well. There's so many things that Dapr can do in that regard, but it does add latency. And this is one of the most common questions I'm getting, especially at conferences. What if I use any type of meshing or service meshing technology, or if I use Dapr? How much latency do I get there? What about service discovery? Does it work better if I use Kubernetes versus when I install Dapr on virtual machines and I manage the cluster myself? Well, yeah, sure. But it can be tricky to use those self-hosted environments. Sometimes you want to consider using direct gRPC rather than doing microservice calls between the microservices using Dapr. Then there are things about security. If you look at this diagram right here, there's going to be a lot of considerations in terms of calling one microservice directly to another and doing service-to-service communication, which is one of features to which Dapr, in my opinion, excels at. Dapr, however, does add additional things that you may not consider yourself, such as supporting mTLS. mTLS is there pretty much natively, I would say. Having API authentication, authorization. These usually have to be handled by your application. Dapr doesn't enforce this by default. But keeping in mind the fact that you have mTLS is not enough, right? You need to implement API authentication authorization yourself. But then again, how do you do it? Do you rely on an external identity provider system? That itself will additionally add latency. That itself will kind of be a boilerplate piece of code that you would have to write against. And there obviously will be in my opinion, there will be a big Pandora's box. Once you open it, right, that my identity provider system can go down. All of your services will go down if you don't implement authorization and authentication correctly. And you also have to be mindful about the secret storage in terms of security considerations, right? Dapr does integrate external secret stores, but it does not store the secret itself. Obviously, this means that you must be aware so that Dapr doesn't expose its APIs publicly without having security controls. And this is something that we have learned, unfortunately, by mistake, where we have left some of the Dapr APIs exposed publicly in a dev environment, don't get me wrong, but it was a way to attack the entire system just because Dapr was utilized. Then there's challenges, of course. When you develop one of these e-commerce-based applications, running Dapr locally is easy. But when it comes to developing or debugging multi-service applications, it does require some additional tooling. Now, you can obviously mock some of these components like state stores and have unit tests run. Sometimes the decisions that you have to take along the lines of which technology am I going to use? Am I going to use RabbitMQs for queuing and whatnot? These decisions can be tricky, and even mocking these components can sometimes be tricky. But for local debugging, Dapr, again, is fantastic, in my opinion, because you can use things even like Dapr logs or Dapr invoke to get some of the local debugging components out of the box. But this doesn't mean that you should not consider, quite the opposite. You always have to consider test doubles or in-memory stores for unit testing and so forth. Dapr sidecars, they always scale with application instances, and they lead to potential resource bottlenecks. And in Kubernetes, there is the capability of auto scaling, but you must account for both application containers and the sidecars themselves to be scaled. And so when you're developing for production applications, I think the title of the session is a bit just tedious. It's almost like developing any application whatsoever. There are things to take into account and to consider. Now, it almost may sound like I'm not appreciating the capabilities of Dapr as much as I am. So let me take you a bit back. We have decided several years back, as I've said previously, we started to develop Dapr-based applications many years ago. And we did that because we were almost sold on some of the capabilities and appreciations about Dapr. And first and foremost, having the single task at hand is literally what sold us. What I mean is the ability to remove any of the tech stack code. For instance, in our dev environment, we decided for one of the early applications that we developed to use RabbitMQ. But we knew that this was a decision we wouldn't want to keep for the production environment. Yet the decision on the tech stack that was about to be used by that time for the production environment wasn't yet taken. So the ability that Dapr provided us with pretty much plug and play for choosing another technology was blissful. From an organizational standpoint, the other thing that we had to account for was that each team responsible of the many components of the application that we're developing was heterogeneous. What I mean by that is that we have had several team members in each team with vast expertise in different areas. So implementing Dapr helps the organization rather than on the decoupling side of things, because you can focus on one area in that team specifically. And in my opinion, this is super, super useful. When you're developing, and even when you're reading books like these, because I was showing you this previously, this is an older book actually. This is the second edition of Building Microservices by Sam Newman, who I argue is one of the authorities when it comes to microservices and the mindset about developing decoupled applications, especially for these years, because microservices is anything but new as a concept. When you're reading one of these books, it almost feels like you're working in an organization, a software company of 600 employees, where everybody's always just developing one project and one alone, and everybody knows what everybody else is working on. So having communication and organization among team members is easy. But there are those problems that inevitably you have to face. And I do appreciate the slide deck, even though I'm not going to speak too much on it, because sometimes it does emphasize the challenges that you have as a developer when you're developing one of these production-based applications. For instance, we have these supposed checkout service here in the middle. Let me bring up the virtual laser pointer that I appreciate so much, this one right here. So the whole idea of this checkout service is that it is responsible of making almost transactable actions with, say, the shopping cart, payment aggregation system, the notification system, potentially the inventory system. There's supposedly some sort of a message broken between, and they all have to work in a very particular manner and fashion. And if things go south, you have to revert them. Now, in software development, as everybody knows, this is easier said than done. If you work on a monolithic application, have a database, then there is, to some extent, some capability for transactions. But these opens up an entire set of different bottlenecks in terms of scalability, page blocks and locks and so forth. If you work in a more decoupled fashion in distributed applications and you have different components that communicate together, you have to think about compensation. What happens if some of these services go south? How do I compete that? How do I compensate that? How do I roll back effectively, right? These are things that thankfully Dapr supports to some extent out of the box, and sometimes you have to write code against them. But the fact that you understand the capabilities of Dapr, in my opinion, this is something to begin with, helps you a lot. What I mean by this is that many of these components can more often than not be considered as actors. Actors is not a new pattern. The way actors are designed in Dapr, if you are to go back to the literature, they're actually virtual actors, or more specifically a virtual actor proxy. And the way you develop code for these is that you write methods, which are almost like macros, where you say you need to do this thing, and then you need to do the other thing, and then you need to communicate with the other thing, and so forth. And I appreciate this quite a lot. And the reason why I appreciate the implementation of the actor pattern here is that every time you realize that a piece of code can be decoupled into smaller chunks that have to work in a very particular fashion, and which should have access to a set of data that has to only be contextual to that particular piece of code, that, in my opinion, is an actor. Think of a shopping cart, think of the checkout service, think of an example. Actually, I'm working more out of fun, in all fairness, on a tic-tac-toe game right now. And it's a Dapr-based tic-tac-toe because obviously you want to over-engineer it. But the whole idea is that if you consider each session of your game, and this is what I did, an actor, and if you play multiple rounds, you can effectively plug and play players, which can even either be humans or just application services acting or randomly choosing X or zero. And I'm doing the same thing with rock, paper, scissors as well, where each game that you play can be a rock, paper, scissors. By the way, do you know the version of rock, paper, scissors, lizard, Spock?
Yeah, I've seen that one.
Heard of it. Yeah, it's a cool one. So I'm doing that as well, just out of fun of it.
Right.
And the reason why I'm doing this is that I want to emphasize to fellow developers how easy it becomes to scale an application once you literally push the throttle on the actor implementation. Many of the things that we commonly develop can actually be implemented as actors. And by doing so, you actually gain a lot in terms of scalability, specifically because of the way you store your data and you query your data. Now, there are a lot of implementation details when I say that. Sometimes there's going to be a requirement for an application that you develop from ground up, knowing your full backlog of requirements, and here comes a requirement which splashes your entire consideration of the way you architected your application, such as run me a report that contains this, and the other data and correlate them together. That's not an easy thing to do, especially when you have your data in multiple services. So how do you do that, right? In other cases, in other scenarios, you develop an application, you develop the microservice, you realize that your data set should contain whatever alongside with your microservice, and here comes a requirement which completely changes the way you have designed your data. So now, so therefore, you write another microservice, another service itself, another project, but it has to continue from original data source that existed in the original service. How do you do that, right? There are considerations when you run a microservice for the long run that are very, very specific to developing distributed applications and microservices. And these are just some of the many challenges that one can come across. Another interesting use case is with tracing and logs. More often than not, we hear this problem about logs not being correlated correctly or not having the ability to correlate them because they may be decoupled. Maybe you have some sort of a service-to-service invocation on one side, but then there's a background service that doesn't have any correlation whatsoever with the other thing, and things go south because the background service might have changed some of the data that was expected by another service. This, unfortunately, happens more often than not, especially in the applications that we have developed, but it happens specifically because we cross one of the very specific requirements that even Sam Newman writes more often than not, namely, never share data across microservices. There are some very, even though theoretical, some very specific requirements that microservices have. And Dapr, if implemented correctly, takes them into consideration. What I mean by that is that when you talk to a data set, if you just use state, fantastic. If you use one of the abstractions of state, amazing. If you use an external service, it's not that you're doing a bad thing, but that external service may be utilized by other components and other services as well. And what I see commonly is that people only use Dapr for service-to-service invocation, for instance, or for pub/sub, and they don't use it for other components. And they have a monolithical approach and mindset towards their data set. They still use a single SQL server, or they use Cosmos DB because it's non-relational or whatever else, but they still treat it as a relational data store. And they have 5 different microservices communicating directly or indirectly, maybe invocating themselves directly, or maybe just using some sort of a broker, which is fantastic. They scale amazingly well, but they use a single data store. That is a big no-go, in my opinion. And even though product managers from Amazon, from Microsoft, from Google, they're always going to claim about the single-digit latency that the data store has. They're going to claim the capability of scaling those data stores and so forth. Not treating your data correctly and not sanitizing your data correctly in that regard from an architectural standpoint does mean that at some point that will become your Achilles heel in your architecture. It's going to be a single point of failure. And no matter how cool the technology that you're utilizing and relying for your data it is still a single point of failure. So that's something to be aware of and mindful about. Many of you might have heard about the Chaos Monkey tests and frameworks. I think that is a very good exercise that everybody should do, at least at the beginning from a conceptual standpoint. Look at one of these diagrams like here. It's so easy to do to begin with. We don't care about technologies. We don't care about protocols. We don't care about handshakes and ID providers. Just put all of the services in a single on a whiteboard or a single PowerPoint or whatever. And the moment you have your ROMs, your rectangles, your whatever they are, your circles, just imagine what would go south if this microservice goes down, right? If you would put a database that stores the data, whether stateful or data that is transient for stateless services, in a single rectangle in this diagram, and that data store is no longer available, the entire application is down. And in that regard, it doesn't matter that you've developed a distributed application. It's still an application that has a single resource in Azure, for instance, and Azure is no longer available. Boom, your application is down. Doesn't matter where it is. And all of this fantastic and exotic set of capabilities of Dapr, of it, for instance, being capable of running anywhere in anyone's cloud, even on premises, no longer matters. Dapr's capability to abstract and plug and play state technology components for storing state no longer matters. And that's only because at some point you decided that you're going to implement NuGet packages for, say, storage or Cosmos DB, for instance. And then you decided that you just want to have a single resource because you want to save some money and not pay RUs that you're not going to utilize. In my opinion, that's a bad decision. I do understand the reasons behind it, but it also means that from a development standpoint, you have not taken the advantage of the capabilities that the technology has to offer.
Hey, I have a question for you.
Go ahead.
I don't mean to cut you off, but I always feel like that chaos and chaos theory stuff is always
monkey testing. Yeah.
Do you have any particular practices, or do you have like a chaos framework that you use, or any type of automation to like introduce chaos into your system that you use with Dapr?
I think so. Initially, we didn't have any experience with chaos monkey testing and didn't use anything at all. There is Gremlin, which I believe is probably the most popular one to begin with. There's also Chaos Monkey that was originally used by Netflix. They came up actually with this term somewhere around 2010 or something like that, unless I'm mistaken. And I'm sure there are more, and I'm not aware of them. But what we did back in the days, and this was even before Dapr, we were using what is today known as web app services, is that we would literally delete application settings from the application itself. So one after the other. So imagine you have a connection string, or doesn't have to delete it, you can just mess it up. And obviously your application will no longer be able to communicate with the database. What happens then? Do you at least show a web page in a meaningful fashion, not waiting for a timeout for 30 seconds for the database to no longer have network instance failure? If you do that, then it is something rather than nothing, right? Can you still render a menu? Can you still stay logged in? These are things, in my opinion, which are baby steps that lean towards a more reliable application.
Okay. Yeah.
Does this answer the question?
Yeah, that does. And Mark just shared a link inside of the chat, so for folks that are watching, hey Mark, I think you might have to reformat that link.
Yeah, because there's actually two links, but they merge into one. I'll reshare.
But I always find it's interesting because if for anyone that builds distributed applications, right? You can't depend on the network. If you have any type of centralized configuration, like that itself is also a service, right? Technically. What happens if that service goes down? What happens if I can't authenticate, right? And you don't want, because you remove one piece of the puzzle, that the whole thing falls apart, right? So I always think like being able to introduce some of these types of things into your application is almost critical. Like you have to do it. It's not like, oh, I'll get to it later. Like you have to do it if you care about reliability and making sure that your customers have a good experience.
This actually reminds me of a very interesting and fun story. So if people watching joined last year's Dapr Day, the one that we had during the springtime, I was fortunate enough and honored at the same time to speak at that event as well. And I was telling you guys about some of the infrastructure-specific production things that I've learned throughout the years. And at that time, I was working on an application, if you remember, that was deployed on a Kubernetes cluster, a vanilla Kubernetes installation, so none of the cool OpenStack stuff and anything like that. It is very, maybe very would sound arrogant. It is significantly more difficult to deploy Kubernetes in that fashion but at the same time, you have full control of all the components that get installed. And once you do it several times over and over again, I kind of fancy that approach rather than using one of the very simple installation capabilities that comes from various forks of Kubernetes. Now, anyway, this was deployed on a cluster. So this entire story was about us trying to figure out why the sidecars for Dapr were not installed. And it took us probably 4 weeks going back and forth with developers, with software engineers, with the people responsible for the infrastructure. And we're going through all of these crazy logs from Dapr, from Kubernetes, and sometimes there were just components that wouldn't say anything. You were expecting the injection service to give you some sort of a information, but there was nothing out of it, right? And some people that we would reach out to would even tell us things like, yeah, typical Microsoft, and things don't work, they can give you any logs. When something does work, it gives you all of the logs necessary and blah, 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 yeah. Which I don't appreciate, right? I think that is highly biased. But it turned out that the problem was due to the fact that in that network, where they were running their production workload, they had a proxy. And the proxy was installed on the machines, on all of the machines. And obviously, when Kubernetes was set up on all of the kube ADMs and so forth, they would pick up on the configurations of the host machines, and they would use that proxy. And therefore, every time we injected the service, that proxy ended up being injected on the kubelets. And therefore, any of the internal communication that our components, as well as Dapr, was doing, was going through the proxy out on the internet, and they would try to hit back on an internal IP address. And that was just not working, right? It was a Linux thing. We figured it out eventually, and we fixed it. But going back to the chaos thing, guess what? At some point, Kubernetes had to be updated. The application was running fine. Somebody updated Kubernetes. It felt like it was working correctly, but all of a sudden, this application was no longer working. Their approach, very infra approach, to tackle the problem was the application seems to not be compatible with this version of Kubernetes. Let's try to revert Kubernetes, reinstall the app, and it should work. And it didn't, right? We already went through the trenches. We know what was going wrong. We know what the problem could have been, and indeed it was that. But going back to your Chaos Monkey, sometimes taking components out of your service is interesting, but sometimes reconsidering the components, infrastructure components that you have in your application is also critical. What I mean by that, Dapr gives you the ability to plug and play and change your technologies almost like you would change your socks in the morning. I kid you not, right? What about developing applications to such a degree that they target a state store for storing trivial blobs in Azure, and then you use an NFS store, and then you use S3, for instance, or whatever else? Test your application like that, because it can be super surprising when it is useful to just plug and play a different state store for your information. Imagine what would happen if during Black Friday, even though you've taken all of the necessary considerations for your application to be highly scalable, reliable, highly available, and so forth, your provider goes down.
Yeah.
Right? The provider is going to pay you, even if they breach NDA, if they breach their SLA, they're going to pay you a few dollars worth of the infrastructure that was not available during that time. But what about the revenue that you're missing if you're an e-commerce application during Black Friday? Every second for Amazon costs several $1 billion worth of revenue. I think that is actually millions. That is something worth taking into account. So
yeah, I agree with you too, because if you think about it, if you have customers, your customer is going to blame you. It's not going to blame the database or the cloud or
definitely not.
Your web framework. They don't care about those people, right? Like they care about you because they're doing businesses with you, and you're the layer on top that they interact with, and so you're responsible for that.
I couldn't agree more. And from that perspective, as a developer, when you're developing Dapr, don't get me wrong, I love the technology to the extent where I'm almost enforcing everybody and every customer, especially when you're doing consulting and so forth, to at least take it into account, if not even develop it upon it. But there are some challenges. Sometimes people underestimate the learning curve, just like you said at the beginning. You go through the quick starts, you go through the tutorial, everything is fantastically working well, and then there are some decisions that you need to take from an architectural standpoint, and you don't know the right answer to that. And that is because there is a learning curve, especially when you're moving away from monolithic applications to distributed applications. Sometimes you over rely on the Dapr specific patterns. You kind of use Dapr for everything. You're even considering that these abstractions, as useful and good as they are, they usually have been developed with very specific scenarios in mind, right? Don't try to use one abstraction for everything. If your application works better by using a relational data store, and you want to use the state abstraction for storing state, which is by definition non-relational, don't use it. There is going to be an API if you guys are not you, because you obviously are aware of that. But if the audience isn't aware, there is going to be a very specific relational SQL, let's put it that way, state store, right? But don't use something that has not been designed for that thing just because you can. That obviously is a pitfall. What I'm trying to emphasize here is that you should always evaluate the feature against your needs. For example, state management, as I've said, is beneficial, but you should always consider like direct interactions with the database if you have very complex queries and so forth, because the initial implementation of state has been designed for that. You have component misconfiguration more often than not. I saw that as a developer and kind of bugs my nerves sometimes because it's not part of the CI/CD pipelines. There is the pluggable components are incorrectly configured, or somebody checks in secrets and then they expect them to work in production, and guess what? Somebody's going to take advantage of that, or they're not working. You should always test your configurations thoroughly, especially in a production environments, and then use the CLI or dashboards to troubleshoot and validate the component health. Debugging can be complex, right? There are logs. There is the ability to correlate logs. You should leverage the observability built-in features, tracing, and so forth, and integrate with tools like OpenTelemetry. I was amazed, by the way. It was probably, it was just before Christmas. I was amazed by how many developers are not aware of the capabilities and OpenTelemetry in general. And they're still writing logs themselves, and they create the separation among the warning level of the severity of the log and the stack trace, and they try to figure out things that already exist. Guys, just use Prometheus and Jaeger and stuff like that for some of these tools. Don't try to reinvent the wheel, because you shouldn't. And Dapr has a lot of the capabilities already implemented. Sometimes the resiliency features are misunderstood, and Dapr has a bunch of retries that people are not aware of, and they implement poly, and in between a poly implementation and a poly policy, which is like a retry capability for a transit error and whatnot, they implement a call for Dapr, which does retries itself, right? Be aware of the capabilities that the tool gives you, and don't try to redo something that the tool already does. There are circuit breaker configurations that you should be aware of, and which can be leveraged in Dapr. There are timeouts that should be leveraged, and one should be aware of. And you should customize those settings rather than use another technology on top of Dapr to shift the way Dapr works. So that's something to be aware of. Sometimes, and this is something everybody does, I've done it more often than I dare to even admit. You add too many microservices with Dapr components, and these create a lot of very complex interactions, and they increase the operational overhead. What I find to be a easier said than done solution is to apply all of these domain-driven designs. Now, I know this is something that, again, from a theoretical standpoint, everybody understands the idea of bounded contexts and having separate domains. But especially when you start an application from the ground up, it's always the same question. What goes into this domain? Should we create another domain for this one? And as a typical developer, I am a typical developer. I eat a lot of pizza, right? I drink a lot of Coke. I'm a typical developer. But jokes aside, it always feels like it's a very difficult decision to take what goes into one domain versus what goes into another. What I've learned is that this is not a decision that us developers should take, but at the same time, we should fully understand the business requirement. Every business requirement always has somebody who's an expert inside the domain. All of these books that you're reading about microservices, they always speak about having a domain expert, somebody who's an expert in the checkout process. It is the same person who you reach out to ask whether you should deduct money from the bank account and then remove the stuff from the inventory, or the other way around. That is your domain expert. It's not a decision that you take as a developer. The only difficult decision that us developer take is whether we should call our variable A or X, and that's it, right? Again, this is a very stereotypical joke, but the reality is that we kind of burden ourselves with decisions that honestly are not ours to take to begin with. And if you understand these domains, then there's a high chance that you're not going to fall into the pitfall of having service sprawl. This is what we should call these to begin with, service sprawl. Another interesting pitfall that I've seen more often, people do more often than not, is when they use the Dapr site store. And this actually is valid for any technology that abstracts data in one way or another. And Dapr is not shying away from that one either. They're using the state store for very high frequency and super complex queries. At some point, somebody decided that we're going to store our user profile information, for instance, as a state. Cool. As long as you know the identifier of the individual that you want to query. But if you want to query at any point in time all of the customers whose first name is Alex, well, you have a bit of a problem there, because the state store is not going to help you. And then we come up with all of these materialized view solutions, which is an architectural pattern, which obviously works, where we store an object called Alex, or that has a primary or the row key or whatever you want to call it of Alex. And then we have some sort of a link to all of the identifiers where the remaining data for people called Alex is, right? It's a materialized view implementation. It works, but why would we have that to begin with, right? Other implementations, which in my opinion are poor, are along the lines of developing a service where you have an actor which is identified by Alex, who keeps track of all the changes of all the individuals, where you have an Alex individual. It's like over-engineering a lot. We shouldn't do that. You should always use state store as they have been designed from the ground up, doing single point operation, reads or writes, and that's it. Not even updates. I enforced one of my teams that I was working with to never use single point operation for patches. It initially sounded like a crazy idea, but we had the problem because of the very high frequency of patching operations. Patching effectively is when you want to only update a single property of a document and not have to read the entire document and then update the entire document. Because of it was an IoT based project. There were extremely frequent changes to a single property. So the decision here was that rather than having one document that represented the state, which effectively meant 50 or some properties of that object, we decided to split the object into multiple chunks, and the ones which had high frequency updates were individual documents, and single point reads would read the information, single point writes would just update the information or update the entire document, but never patch it. Patching is effectively just changing a single property rather than all of the properties. This increased the reliability and the scalability of the application by an exponential, literally by a magnitude. We could do more operations per interaction with one device, because it's an IoT operation by the terms of hundreds times more, which was quite interesting. Subtopic management. Every time I see a new team emerging and using Dapr for the first time, they have to pick a name. And again, picking names for developers seems to be a bit of a struggle. And they use topic 1, and then they want subscribers, and they use sub 1, sub 2. And then at some point they realize, what was topic 1 for? I don't know if that was a good decision. Again, if you try to plan your pub sub, and I know this sounds easier said, again, it's very difficult to actually do. But if you do carefully plan and think about the flows of your messages, you normally don't have this problem to begin with. If you implement the necessity for pub sub within a domain, this is not going to be a problem that you're ever going to face. But again, a pitfall that comes more often than not, just one of the things that you should be aware of. The dependency on the Dapr APIs. Sometimes we overcommit on the APIs without actually considering a fallback strategy. And this can make it harder to migrate away from Dapr in the future. Again, this is something that maybe we wouldn't want to hear at a community call for Dapr. But if you do design your services to abstract Dapr APIs where possible, it makes it easier to replace Dapr with alternative solutions when needed. And what I mean by that is not that you're going to ditch Dapr entirely, but rather there is the potential capability to shift from one component to another if there's ever going to be a need. But I want everybody here on this call to read this actually the other way around. Imagine that you are working on a brand new application, and last November, your manager realized, or your CEO realized, that AI is the next big thing. You need to have AI in your application, and you need to implement an LLM. And you started to work with the APIs, say, for ChatGPT. And then you just learn about this new thing, DeepSeek, and you don't want to be missing out. So now you start working on DeepSeek. And then there's another thing, because DeepSeek is no longer so cool. So now there's this other thing that they develop in South Africa. And now there's another thing that they develop in Transylvania. Developing amongst all of these APIs, I don't like it. What about having an abstraction for these? And guess what? Dapr has it. So what I want you to take away from this challenge and pitfall that I've realized is that you should have your code written in such a fashion that you leverage the abstractions without being dependent on the abstraction itself. So what I mean by that is there's a component nowadays in the newer versions for AI. Use it, but use it in a fashion that if you ever need to change the actual API that you're utilizing to something else, because there may be something else at some point coming up, it's not difficult to do. So you understand your domain again, right? Security oversights, more often than not, we all know it, right? We love TLS, quote to quote. Double mTLS means double trouble, so double love, double quotes. More often than not, we forget to enable. You should always enable and validate mTLS and configure fine-grained access control, and make sure along the same lines that network policies are correctly put in place. And you have Dapr implemented in the Kubernetes. Make sure that your components can talk to each other and the network policies are not preventing the communication amongst your services or to Dapr, or the other way around, especially if you have many different namespaces and you prevent the communication among the namespaces. And you decided that Dapr system namespace is going to be a better choice for your Dapr components. All of these things can go south just because you've implemented the best practices, but you forgot about some of the defaults there. Sometimes using some of these mismatched versions of the Dapr runtimes and the SDKs and the CLIs, and they all can lead to a lot of unexpected behavior. So always keep Dapr up to date and make sure that you don't have components which are not aligned at the same version. I've seen this twice, and therefore it made it up on my list of developer challenges and pitfalls, but obviously there may be more than these. Overhead from sidecars, running a service can introduce obviously latency and resource overhead and exhaustion. Always keep in mind and remember that you need to scale your sidecars just as you scale your applications to begin with. Kubernetes is complex. Nobody says it isn't. Dapr isn't gonna allow you to shy away from the complexity of Kubernetes. But if you do use it with things such as Conductor, for instance, or if you do use it with Azure Communication Apps or any of the other things that have Dapr implemented natively, then you can actually leverage capabilities such as managing deployments and managing secrets and configurations and so forth much easier. And you won't be as overwhelmed as normally others would be, especially if you don't have any experience or expertise with Kubernetes. Skipping comprehensive testing of Dapr features can lead to a lot of these unexpected runtime issues. The solution, in my opinion, is always to test your Dapr integrations and to make sure that you thoroughly test your applications and the integrations in the testing environments, which obviously must mimic production environments as closely as possible. And don't ignore the observability capabilities during the development. This literally helps you diagnose issues, especially in production, more often than not. When it comes to logs, I cannot not remember, let me put it that way, double negation, the issue that we have had when the sidecars were not implemented. And it was a bit annoying back then. I'll give you that. I probably told this story more often than I should have. It was a bit annoying because the moment one of these errors comes up, normally what you do initially is that you obviously go over to Google or Bing or whatever. Whenever one of these very crazy errors along the lines of, I think the error that we got was along the lines of unable to get SA tech token pipelines or something like that. And then a UID, a GUID, which was supposedly a UID. You don't know what to do with that, really. And a lot of these logs that you use, and this is not specific to Dapr, but especially in Kubernetes, are not very useful logs. So you copy the log message or the log code or whatever, you paste it over in Google or Bing, and then you may come across a GitHub issue that is titled something that is closely resembling your problem. In our case, it was Dapr sidecar not injected in pod or something like that. So even though we didn't say anything specific to Dapr, the error itself helped us figure out if there was a discussion already going on GitHub related to that problem. But in that case, for us, it was a log that was generated that took us to an issue that was closed several versions back, which supposedly was a problem that was no longer appearing, but it was for us, right? So the logs sometimes don't help, but sometimes they do. What I'm trying to emphasize here is that you must make sure that you collect these logs from the right place. In our case, when we had that problem with the sidecars not being injected, the logs were actually on the Kubernetes side, in a place where we would never look, in all fairness. So by not looking at dynamic admission control and not looking at ACLs and by not looking at ports where we thought that the problem was at, but rather by looking at the API server logs of Kubernetes, we actually figured out what the problem was. Why am I even saying this? Logs, unfortunately, especially in the infrastructure side of things, especially in Kubernetes, are in a bunch of different places. So you need to know where to look at. You don't want to make the same mistake, let me put it that way, of having your IT pros, your DevOps, your customers, or whoever else is managing your application, of looking into various places for logs, looking into your checkout service for logs, looking into your notification service for logs, looking into your shopping cart service for logs, and so forth. You want to correlate them together. You want to leverage things such as observability and so forth. So these are things that I have seen by developing Dapr-based apps. These are things that I have seen others do more often than they should have. And if you're careful enough, then Dapr is definitely one of the technologies that helps you create a revolution when you're writing software. And this actually is a bit of a inside joke for me, or inside context, because for those of you who have seen my sessions on the revolution of the automotive industry back in the day, would know the reference as well.
You know, what I loved about all those things that you've shown, one, I think they're all very relevant, but two, I think those are things that are solved like when we work together, right? And what I mean by that is like, I feel like when we build distributed applications, like it's a team sport, right?
Yeah.
And it's a team sport from the perspective of we have to, one, us as the Dapr folks, like we have to provide the information, like the knowledge, the resources, the documentation, the samples, so that people can know, oh, these are some things that you might run into, right? And then here's how you can mitigate those issues, or here are the conversations you need to have, you know what I mean? So you can, you know, prevent some of these things from potentially happening or having a huge impact in the future. And then also to, you know, us working, you know, on your team, trying to figure out, like you said, like I need to talk to the domain expert about this thing. I need to talk to the testing person, the designer. Like we all have to work together and communicate effectively for those things to happen, right? And so that, and that's what I mean when I say, I feel like building applications in general, distributed or not, it's a team sport, right? We all have to participate equally, you know, for us to be successful.
I couldn't agree more.
Yeah, good one, really good one. Yeah, thanks so much, Alex. There's a lot of valuable nuggets you shared with us, and also quite a lot related to testing as well, right? And I think also 2 weeks ago we also had some nice, I think. WireMock was mentioned there that some people were using for mocking some other services and making testing distributed applications easier. Yeah, I think in general that's probably a good area also for the Dapr project to spend a bit more time on and to give some more feedback or some guidelines on how to test distributed applications. So yeah, it's on my to-do list to look into that.
Awesome.
Great. Yeah, if people still have questions for you, they can probably find you on the Dapr Discord and anywhere else they can contact you.
I think LinkedIn is probably another good way besides Discord to reach me. I'm no longer, for some reason, I find myself no longer as active as I used to be on Twitter. Sorry, X. I still call it Twitter, which kind of says it. But yeah, LinkedIn is something that I still would like to have.
All right. Thanks so much, Alex.
Yeah, thanks a lot for having me to begin with. Loads of fun.
All right. Let's move to
the show and tell time.
The next section, community show and tell. Yeah.
Nice.
So let's see what we have. So there are a couple of upcoming events where there are some Dapr sessions. First up, actually this week, it's called Tenerife Winter Sessions. I definitely want to attend there. Tenerife sounds very nice. It's a hybrid event though. So I think one day is virtual and one day is like in person. And Sergio Parra will give a Dapr related session there. He'll do one of the virtual tracks, so you could just watch this on YouTube. And 11th of February there is Cloud Native Luxembourg, where you can go to, and that is just one session dedicated about Dapr, so breaking barriers with Dapr, simplified and portable cloud native architectures. So if you're in the neighborhood of Luxembourg, please go there. I'm giving a session on the 13th of March in the Netherlands at the Future Tech Conference. Also in March, in the end of March, Divine Audacy is giving a session at SRE Day, building open source do-it-yourself private DBaaS with Dapr. That sounds pretty interesting. And then we have Nico Vermeer giving 2 sessions. I already mentioned last time. One at the .NET Days of Romania, it's beginning of May, and then end of May at NDC Oslo.
I've actually been to the .NET Days a few years ago. That's a really good conference. It's a lot of fun.
Yeah, I agree. Yeah, that's very nice organizers. Very high quality sessions there. So yeah, if you're in the area there, definitely go. And NDC conferences are also really well organized. Then what I found on YouTube, a couple of videos. Again, there's like a new video by Rodrigo about Dapr. So he's doing like a whole Dapr series. I think this one is the 7th episode in there. So this was about sequence management API. Then James Eastman, who was doing a session in the last community call, is also doing some series on event-driven architectures, and he's also mentioning Dapr pops up in this video. Then Will Valida, one of the other Dapr Meteors, gave a session at Microsoft Reactor, building cloud-native applications with Dapr and Radius on Azure. It's also a very nice combination. And some of the KubeCon videos have been published recently. So also the session by Jeroen Schneider, Dapr Road Ahead, GenAI APIs, distributed scheduling at scale, and what it means for your platform has now been released. So this highlights basically many of the new things coming in 1.15. Some of the social messages, mostly LinkedIn. So definitely people who written some blog posts about Dapr. Again, I mentioned from James, he's now also using the Rust SDK for Dapr, which is cool to see. Some people are doing a workshop in the US. Some people gave like a summary of a Dapr session that I gave 2 weeks ago in the Netherlands. And again, Victor mentioning that he's doing some nice experiments with Rust and Dapr. So yeah, the Rust is, I think, gaining some more popularity with Dapr these days, which is nice to see. Yeah,
that's awesome.
Yeah. Discord updates. So there's a new category on Discord. So there's now a section called Enterprise Providers with 2 channels, one for Digrid. So if you are interested in Digrid products or have some questions about those products, Conductor or Catalyst, you can go ask them there. And there's also a Microsoft channel within Enterprise Providers. So for instance, if you use Azure Container Apps with Dapr, that's a good place for you to go to.
Nice. And in those channels, obviously the community folks are in there, but are there folks from Digrid and Microsoft in those channels that are just occasionally monitoring for questions?
Yeah, exactly. Yeah, they had so had the Dapr Discord already had people from both companies present there, but we didn't have like a dedicated place for certain integration questions. So that's why we created these channels for people who have this need. Yeah.
Awesome.
And some other Discord news from people I'd like to thank. So thank you, Elena, for being very active in the Python SDK channel, helping out Patrick. And also thank you to Cassie, helping out in the job scheduling channel, also helping out the same Patrick, who had quite some questions. So thank you both very much. And yeah, please come join us in the Dapr community. So the Dapr community is more than just this community call. It's more than just the Discord. And we have different channels where you can ask questions. And we would love, of course, if you create some Dapr content, right? If you're giving a Dapr session or you wrote a blog post, we would definitely like you to inform us about it. And you can actually make a pull request in the Dapr/community GitHub repo, and then you can win one of the Dapr badges. Also, if you're contributing source code or documentation to any of the Dapr repositories, we'll also give you a badge for that. So you can collect a lot of different badges if you're contributing to the Dapr project. And as mentioned before, and also Alex was using the Dapr open source slide deck. So that's there for you to use. So some people use it like for internal knowledge sharing. Some people use it to give like public presentations. Feel free to use it any way you see fit. I actually just made a pull request to update it for release 1.15. So very, very soon there will be a new version of this slide deck for you. And in general, thank you for being a community supporter. So thank you for watching, and thanks for mentioning where you're from. And I would like to see you at the next community call in 2 weeks.
Yes, folks, definitely love to see y'all in 2 weeks. You know, Mark, we need to get some new badges, man.
I agree. Yeah,
we need to get like a 2025 Dapr community. We need to have a graduation badge. Now that I think that's what we need.
Ooh, okay.
Graduation badge.
Who will we award?
We're brainstorming on stream. I apologize.
Okay.
I would love to
yeah. Okay. Let's continue this offline. But I do agree. We need some fresh stuff. All right. Thanks, everyone. See you next time.
Bye, folks.